webinar, Felix and Clemens. We're here to talk about Lemon AI, and I would really love to ask you about like your startup journey as well. So we're going to be talking about fine tuning. We're going to be talking about like how you guys land on this idea, and yeah, that's it. Want to introduce yourselves, what you're doing, all that good stuff.
Yeah, let's do it. Maybe I'll start. So yeah, Clemens and we've been working together since 2021 now, basically after we graduated from our masters, which we did together. That's how we met. We've been experimenting quite a while, quite a bit in the past. Had different products we evaluated, had a few products where we had paying customers for, which we moved away from for several reasons. And especially in the last months, we focused, and I think that's maybe due to the nature of the Gen AI space, focused on being fully hands-on and trying to build a product based on problems we are solving for other users. We have a few users which we talk to quite generally to understand what their issues are with the current adoption of Gen AI technology. And we saw this pattern of struggling with expensive proprietary models that also don't really perform quite well. So the accuracy of the tasks that they're should solve is not high enough. And that's where we thought about, okay, how can you address this issue? How can you improve accuracy and at the same time reduce costs? Reducing costs, I think this thinking is quite straightforward. You just host your own model, a smaller open source model. But the question is, how can you get the model to perform well and to even perform better than the proprietary models like GPT or Claude, which our users are currently using. How you can do this is basically what I'm giving the talk about. Clemens, did I miss anything regarding our startup journey, regarding us?
Maybe I can add some color. So my name is Clemens. I'm doing the non-tech things. So I mostly just do what you do a lot. Kind of these product talks, talk to people doing fine tuning on a regular basis, or talk to people who are just getting started with GPT-4, that kind of stuff. Maybe to kind of give you a bit of a better idea of why we're doing this kind of building approach now. It's a very different space, obviously, as you said earlier. It's very early, right? And so it's kind of essential to just keep building things and keep an eye on what's next. In the space we used to be in, data observability, that was really different. There was like an established stack, and the big task was a bit like, how do you fit into it? How can you differentiate in the presence of all of these companies? And that's what I think makes this really exciting. And Felix will obviously share a lot about this kind of exciting stuff we're looking at right now. But there isn't really any established stack when it comes to model fine tuning. When it comes to open source models in general, and that's what makes it so fast paced as well, because of course things are changing all the time. So we've really kind of shifted our focus, and are now in this very, very different environment. Still very early stage,
Cool.
Of course.
Sounds great. So a quick question on the different markets and different product type. So you said that the observability product that you guys worked on before, that was like almost like a more established market. So are you facing some sort of like crossing the chasm thing here? You're like working on Gen AI and trying to figure out what kind of customers would actually want to use this today as opposed to like 5 years from now?
Yeah, for sure. I think what's surprising to us is that people who should be, or where you would expect them to be kind of sophisticated about this stuff, actually aren't. And very technical people say, look, we're just experimenting with GPT-4. We have this internal use case where we retrieve some knowledge, and that's pretty much it. We are very interested in fine tuning, but we haven't really touched it because it's a bit too vague. So I think, for us, it's actually surprising how difficult it is to figure out what let's say the perfect ICP will be for what we're building, because I think everyone is just like experimenting and figuring stuff out. We've seen some patterns. For example, with some financial institutions, you see quite sophisticated teams who are like willing to take risks. But in general, it's actually very, very difficult to kind of generalize. And so it's extremely early. I think it's in reality, it's even earlier than what you would expect when you spend like an hour on Twitter, right? So I don't know if that answers the question.
Yeah, that definitely does it. So I guess my thought would be, if we run into somebody who has like an AI head of AI or whatever in some large enterprise, they're probably messing around with GPT, and not something too crazy. So going back to Felix, you mentioned some of the problems that you guys ran from the customers that you worked with that keep recurring or keep coming up. What were some of like the most obvious like quick wins that these people could do to kind of like optimize or increase their performance using like open source models?
So I have basically 5 slides. More than happy to jump into those in a second. But to give you a quick answer, not doing classification tasks with expensive decoder-only models like GPT or Claude, but using more like encoder-only models like BERT or DistillBERT, which are way smaller and way easier to host, quite simple to fine-tune. And if it's just about classification, they do the job very well. And we were surprised how many classification tasks our users or the users we're talking to are handling with like GPT-4 or Claude with a very long context window. So it's over engineered in a way.
Gotcha. I forgot you have slides, so feel free to share your screen.
No worries. Those slides are more like guidance. It's not a heavy presentation, I promise. Let me quickly set up my laptop. I hope you can see it. You can. Okay.
Yep, perfect.
All right, let me jump back to the beginning. Yeah, so the overarching pattern I already mentioned with our users that we came across was, as I already mentioned, they're using proprietary models. They're quite expensive, and they're not performing well enough for them. And that's what we are currently working on improving. We already made some progress and had some smaller success stories, like for instance this encoder only model approach. Mostly this is an ongoing task, and for us it's quite exciting because we feel that we can really make a difference here. Just as a side story, in London there was an EAC hackathon like 2 weeks ago, and I basically spent the whole night fine-tuning different models. I think in the end I fine-tuned 3 different versions. None of the versions exist anymore, but it was definitely a fun way to basically do the daily work and pitch in the end what you've been working on. The outcome, one of those 3 was performing surprisingly well, and yeah, it was just very interesting to share it with the community. Why? So maybe as an introduction, why we even came up with this idea of thinking about open source models. I think one of the main reasons is that you if you ignore those big open source models like the 70B versions, the Mistral model with 7 billion parameters out of the box doesn't really perform well. But if you narrow the purpose of this model down quite a bit and have a very specific task that you want to solve, those models can perform surprisingly well. And all you have to do, and that's easier said than being done, is to fine tune those models for the given task. We've been working on different use cases with a few different users. We have some in the pipeline, but the two most important ones that we are working on the first one is a web shop product categorization. We have a hedge fund in the US who acquired a web shop, and their web page is catastrophic. It's basically the navigation just doesn't work. They make surprisingly a lot of revenue, but yeah, the user experience is actually quite a pain, and they want to completely reclassify the product catalog, and they're doing, or they did this with GPT-4, and they already had a quite large bill in compute costs because they just used it for a classification task, for a classical classification task, which you don't necessarily need large language models for, because the input is quite straightforward. It's a very short description of the product, and based on this, you need to classify what kind of product category makes most sense. And this was our first success story, because there we just took a BERT model. We generated some classification synthetic data. And we did this with GPT. So we used GPT as a teacher model. GPT generated a classification tree based on one file I gave it input for, and we trained this BERT model based on this. And this BERT model, this encoder model we fine-tuned, can now be used for new upcoming product categorizations of products that enter this product catalog that they have in the backend. Another one, which is way more complex, and I'm currently working on, it's a financial. It's in the end, the input is newspaper articles, and those newspaper articles need to be analyzed, and any financial crime that is mentioned in this article needs to be extracted and mapped to specific entities that are also mentioned in this article. And this is on top of it. This is all done in Latvian language, so that's an additional complexity that we're currently facing. And I'm going to jump into this use case because it's I think quite interesting to discuss how you could approach something like this in the context of fine tuning. So maybe in general, what challenges we are facing with use cases about with fine-tuning open source models, where you have to reduce costs and you have to improve accuracy. I think there is this common saying in machine learning where you say trash in, trash out, and that's based on our experience. As I mentioned, I've been fine-tuning a few models now, and it's definitely true. If your data isn't right, the fine-tuning efforts, they're not worth it, because the output that you get out of those models, often it's even worse than just using the foundational model. So it's key to use a very high quality data set for training. And the issue with all of the use cases we are working with and we're going to work with, they're all facing that they don't have labeled data at hand. And we basically have to generate synthetic data that represents the data that is then going to be that represents the original data. We have one use case, one upcoming use case that even requires us to do so, because they're not allowed to use any data of their users for fine tuning. So on top, you have this data masking requirement that we have to deal with. And yeah, so we started off with GPT-4 for generating those synthetic data sets, as I mentioned, with the product catalog use case, because it's just super accessible, and you can just do some few shot prompting, and you get quite nice results out of it. But if you want to really generate a large data set for training, like 10K, 20K, 30K, sometimes you even need more. It gets quite expensive very quickly, and that's where we decided to move towards running our own teacher model, which is just a Mistral 7B or a mixture for the more complex use case, which with few shot prompting and a very narrow task definition can also produce quite well-established results. The second issue that we're facing is complexity, and complexity is the complexity that the current task is designed for. Works somewhat with GPT-4, but it's just too expensive to run. And right now, open source models out of the box or broadly fine-tuned, they can't handle this degree of complexity. They get confused, and they're missing out on specific tasks, subtasks that they need to solve. And here it's just key, and that's one of the major takeaways for us, to narrow down tasks as much as possible and fine-tune very specific to a given task. Regarding the approach that we were following here, so I guess we were facing multiple challenges with those use cases. I already mentioned a few, but especially with synthetic data generation, you need to ensure that the data that you're generating is of high quality, and you also want, and this is one of the major issues that you have to deal with when generating larger training data sets, I mean, even with 1,000 data sets, you can have a bias in your data. So it's not even an issue with larger data sets. It's a general issue, but they're I guess easier to spot. And we came up with an evaluation approach based on topic models and regression analysis, in order to understand how is the data that we're generating, how are the records distributed. And the topic models, essentially, they're looking at the records that are generated, what content those records contain, and what topics they're talking about. And then we check how the different topics that are covered by different records are distributed over the whole population that was generated. The regression analysis is more like on a macro level of the content that is generated per record, and checks how similar are those records to each other. And also, we are kind of following an iterative approach when we think about synthetic data generation, where we are not generating the whole data set at once, but more in different requests that we're sending to the model in small chunks, and we are continuously doing this evaluation that I already mentioned. I visualized it. Let me quickly go through the visualization and kind of explain how we are currently approaching it. So you have your teacher model, your Mistral or Mixtral or whatever open source model you want to use. You have a very narrow task definition. So the prompt that you're defining to generate the synthetic data has a very very simple objective. So there are not multiple dimensions that you're trying to merge. There are not multiple tasks that you have to solve in order to come up with the synthetic data. It needs to be a quite straightforward task that you're trying to solve. And then you do some few-shot prompting. 10 great examples are already quite helpful. So 10 great examples could include examples for the expected outcome, but also they could be great in a way that you also cover examples that cover unexpected outcome. Then you generate a specific number of synthetic records per request. You can run this async, so you don't have to wait for ages to come up with the synthetic data. These records that are generated are then evaluated by this evaluation approach I mentioned. If we decide, or if this approach decides that the data is distributed as expected or as desired, we add this to the synthetic data set. And if not, that's one of the manual thing, or the manual step you have to perform in this approach. You have to adjust your model, your prompt, and also maybe have to redefine how you provide those few-shot examples, which examples you provide. It's in the end a small part of prompt engineering that you have to do in this specific scenario. Once this data is generated and distributed, you essentially check how many synthetic data was already generated, how many records do I already have, and the loop basically goes on until you reach your final goal of the number of records that you want to have. And if you have those records at hand, you do the fine-tuning part, and that's something I didn't mention yet. But the fine-tuning itself, it's quite straightforward. The solution's out there, and I'm going to jump into what technologies I already work with, which I tried and which I liked. Going to jump into this in a second, but fine-tuning itself is not really a challenge. It's quite straightforward. The main thing is having great data to fine-tune. Maybe just one thing regarding the teacher model that we're using. Mixture 7b works well for the more complex use case, but you can also go with a more lightweight one, because Mixture 7b is not Mixture 7b, it's Mixture 8 times 7b actually. So a Mixture 7b is way more lightweight, and you can use this for more simple use cases. But you can also go with GPT models here. You just have to be aware that generating large data sets with GPT-4 can be quite expensive, and also it's a question of latency. If you host those open source models in a proper way, you can get very good inference time out of those open source models, which definitely beats the inference time of GPT-4. So regarding the financial crime use case, the objective of this use case I already mentioned. They want to have higher accuracy, and they also want to lower the cost, because they're using Claude 2.1 and it's super expensive to run. And that's why we took on this use case, because we saw great potential in first of all, improve the accuracy and also lower the costs. The biggest challenge is that we can't work with the current setup of regarding prompts that were defined, because the prompt is way too complex. That's what I already mentioned, that you have to separate the different tasks that are handled by the existing prompt. And you have to split it down. You have to narrow those tasks down in order to improve the accuracy with open source models. So you can see all those 6 tasks that are defined here: to understand a newspaper article in Latvian language, to retrieve financial crime references from this article, to classify what type of financial crime was happening, to translate the reference that you retrieve, because not everyone on the team is English speaker, fluent in Latvian language and only speak English. You have to translate it. You then have to map this reference to an identity that you retrieved in a previous step from the newspaper article. This entity could be a person, it could be a location, an organization, and you have to understand what role did they have in this crime? Were they actively involved? Were they supporting the crime? Were they the victim, or did they have another role? You have to do all of this right now in one single task performed by Claude, and it just doesn't work with those open source models, at least with the ones that you can host for a reasonable price. So you basically have to do fine tuning here, and that's what we did. We did split up the tasks of the prompt. We took the classification tasks, and we're currently fine tuning BERT models, like for instance, like with the other use case. And for those analysis tasks, for instance, retrieving financial crime references, we're currently fine-tuning a Mistral 7B from OpenHermes. We have to do different. We have to do fine-tuning on different dimensions. We have to first of all improve the Latvian analytics capabilities, and then we also have to fine-tune on understanding financial crime and being able to map crime to specific persons, locations, and organizations involved in the article. And yeah, this is ongoing, as I mentioned. It's quite some work. There's a lot of stuff that you have to take into account. But yeah, I'm based on what I'm seeing right now so far. I have to do some final benchmarking, but right now it's definitely worth the effort, and you can really get some very good results out of it in terms of improving the accuracy on the task level, and also reducing your overall costs, because you can host a Mistral 7B fine-tuned one for like I don't know, $400, maybe $500. And those encoder only models, they're quite small. So hosting those is not a real issue, because you don't have this this hardware overhead of relying on strong GPUs. I mentioned I used some tech or a range of technologies for fine tuning. This is an overview of which technologies I most intensely looked into for fine tuning. The infrastructure for fine tuning. I think I used different approaches. The one that worked best for me was the GCP compute engine, which in the end is only the VM coming from GCP. In combination with SkyPilot, which basically looks up for you which is the best or the cheapest VM that you can spin up in different regions. Google Colab is also surprisingly nice. I just subscribed to the $10 subscription, and so far I always got access to an A100G for doing the fine tuning, which is amazing. I looked into different tech frameworks for fine tuning: Unsloth, PyTorch, so raw PyTorch for encoder only model training, Hugging Face, Axolotl. I really like Unsloth. It's very nice, and you still have access to the code. Unsloth, it is based on Hugging Face API. but they twisted it a bit and made it more performant and different on different levels. So yeah, I can just recommend you trying Unsloth. They allow you to fine tune your model in different ways, and the user experience is quite nice. Axolotl is also nice, but you don't have access to the code. You just set up config files and then you just watch. I personally like looking at the code and trying to at least to some degree understand what's happening under the hood. Yeah, and then regarding inference, because this is also a topic that we are thinking about in our work. SkyPilot again is doing a great job for deploying in cloud environments. I also tried Modal and Hugging Face, but I in the end just went with a VM because this worked quite well. For Mistral 7B, you can, for test purposes, you can use a T4 GPU. The token per second performance, or more like speed, is quite low, but it's fine for very simple test scenarios. And using an A10G to host it on a spot instance, I guess is the sweet spot for hosting those 7B models. If you do quantization and basically go with Llama CPP, you can even go lower with GPUs. Yeah, I think that's mainly it. What's next? So we're doing those use cases. We're interacting with those users because, first of all, it's super interesting to work with them because they're quite technical. It's very interesting to see their perspectives on things, and it's a great opportunity for us to understand what parts of the work that we are doing for them can be basically abstracted away into a solution. All I'm trying to do is to understand the similarities between the use cases and take those similarities and wrap this up into a solution. And the best shot that we're having right now, and it's a quite exciting one, is to build a solution that allows you to take those very complex tasks that you would try to solve with a proprietary model, but you don't want to because for several reasons. For instance, accuracy is too high, the latency is too high, or you want to avoid costs, and you break this up and have the option to basically define a workforce of decoder only models and encoder only models that work together to solve this complex task. And this workforce then can be fine-tuned quite easily on the platform that I'm thinking of right now by synthetic data that you generate for those very narrow use cases. Yeah, that's basically it. Happy to answer any questions after this let's call it presentation. And if you have any other questions, if you're watching this video at a later point in time, those are my contact details. Feel free to reach out. Happy to answer any question. The same goes for Clemens, of course.
Great.
Yep.
Really awesome presentation. Do you guys still have time, right?
Yep.
Okay, I got like a dozen.
Nice.
Let's just start on the easy one, and feel free to answer them like shortly or quickly. First one. So on Google Colab Enterprise plan, can you run multiple ones at the same time?
You mean multiple notebooks?
Yeah.
Didn't get that far because I didn't get access to an A100.
Gotcha. Yeah, those things must be rare.
Yeah, I'm surprised that I get access with this $10 subscription. I don't know why. Maybe this is going to change quite soon.
Yeah. So question about like the last slide that you have. What are some of the best use cases for like decoder only models and encoder only models?
So decoder only models. If I take this financial crime use case, is it's really understanding relations between different elements in the given input, and basically making up your mind what classifies as financial crime and who's involved in this crime. So more like this multi-dimension analysis. And encoder-only models work very well for classification. So classifying products and defining product categories based on the fine-tuning, or even retrieving entities from text and understanding, is it a person, is it an organization, is it a location?
Gotcha. Can you give an example of like a good narrow task for an LLM to do versus like a bad one for open source models?
Sorry, come again?
So you mentioned that Claude 2, for example, your client used to use that, and they would stuff a bunch of tasks for it into the prompt to make it to do
sorry.
Yeah. So for open source models, like what would be like a good example of a very narrow task for it to do versus like a bad example of like too many things that you're trying to make it to do?
Yeah. So maybe taking this use case again, doing 3 different types of classifications, then retrieving financial crime and understanding who's involved in the crime. I would say this is a bad example for a narrow task. But only taking one classification task and retrieving entities from the text is a great example for a narrow task. Also, only retrieving references to financial crime from the text is also a great example for a narrow task. The mapping to the entities that are mentioned in the text could be handled by a different model that is fine-tuned for this narrow task of mapping.
Interesting. What makes a good teacher model?
Great question. In an optimal scenario, if you have data at hand, a fine-tuned one. If you don't have data, I guess a good foundation already does the job. It's more about the prompt that you provide and the examples that you can provide. But essentially, if you have labeled data and you're able to fine-tune your own teacher model, maybe not to a domain, but a more generalized task, or for instance, multitasking, where you have access to open source data, fine-tuning this teacher model can be very beneficial. But in most cases, this is not realistic, and you have to go with the foundational model.
Okay, so I have this question that I'm personally very interested in and invested in. In what case is it against OpenAI's terms and conditions to like use GPT to generate a bunch of synthetic data? For example, if I were to use GPT-4 first for my app, and then get a bunch of data, and then fine-tune like Mixtral or Llama 2, would that be against terms and conditions, or is that fine?
Yeah, as a matter of fact, I actually know the terms of condition regarding this question. We had a user or potential user we spoke to, and he said they collected all of the data that they generated with GPT in order to fine-tune their own model. And then they read the terms and condition, and you're not allowed to fine-tune another model based on the output of GPT. So yeah, unfortunately, you can't do it. But yeah, it's a question of I guess a question of how seriously you take those terms and conditions, and how important the use case is to you, and what the risk of being sued is.
I think in the end, it depends on the commercial use of it, right? If it's an internal use case, I think nobody will complain. If you want to use the model you're about to fine-tune commercially, that's a different story, right? And I mean, there have been cases where people have, of course, kind of ignored these terms. I think ByteDance did this until they got blocked. So yeah, I'm not sure if if you have an internal use case, anybody will complain in reality.
That definitely makes sense. Maybe like not build like an entire business off of like
yeah, exactly.
that's
Yeah.
like a huge amount of risk. Any general advice on like masking data or like dealing with like PII or personal identifiable information?
Yeah, great question. So how we are approaching this, and I only ran some tests so far because this is this data masking use case I mentioned is more like the one in the pipeline. We're doing it with prompt engineering right now. But to be quite frank, I have to look more into detail what kind of technologies are out there, because I'm sure there are some libraries out there that do the heavy lifting, at least to some degree. But yeah, there is something you need to do on top, I guess, and I would assume that this will be handled then by prompt engineering.
Gotcha. Is there any downsides to generating and using too much synthetic data to fine tune a model?
If the data is of high quality, no. And with high quality, I mean, for instance, what I mentioned, the distribution, so you don't have a bias where you have topics covered very intensely and other topics are very sparse. No, actually, just has to be of high quality, which is easier said than being done.
Gotcha. Makes sense. From your experience, what has been like the best model for entity extractions or classification? Your favorite model?
So great question. Since we're facing this issue that we have Latvian language, I had to fine tune it. And I just use BERT for it. So yeah, I'm going with BERT, but there are a few out there that work very well for English language. Yeah.
And speaking of Latvian or translation, what's like the best approach when dealing with content that needs translation to maybe like English?
You mean how to do the translation?
Yeah. So would it be better if you use like a model that is like multilingual, or would it be better if you like use another model to like translate and then go back to your pipeline to do your like data engineering or classification?
Yeah, okay, got it. Great question. I didn't look too much into multilingual models. I mean, Mistral 7B is out of the box. You could call it multilingual. It has some basic understanding of Latvian language, so it can do the very basic analysis. But if you have quite complex formulations and you're not quite sure if a person, for instance, was involved in a crime, there you just need this detail. And I guess how you get there is get as much Latvian text as you have and fine tune the model on it.
Gotcha. Makes sense. One last question. So you mentioned topic models. What is an example of a topic model?
So topic models, they are essentially going or looking at the text you have or the input you have at hand, and are trying to understand which topics are covered in the text. And then it's another type of classification where you just try to understand, okay, what kind of content is provided. So it's in the end it's quite similar to those BERT models that we're fine tuning.
Awesome. That's all the questions that I have.
Amazing.
So,
Yeah. Thanks so much. If there are any other questions, as I mentioned, always happy to answer any questions via Discord, LinkedIn, whatever works. And also, if you're watching this and interested in fine tuning your own model, yeah, come speak to us, because we're quite excited and enthusiastic about what fine tuning can do.
Yeah, and we're gonna schedule another one at some point, because I haven't had a chance to talk about like startup stuff with you guys. That's like my main concern right now. But
Nice.
thanks for hopping on. I gotta add Clemens to the Discord as well. But appreciate
Please
your
do.
time.
Thank
Hope
you.
best of luck with all the fine tuning stuff, and we'll see you guys in the Discord.
Yeah.
Awesome.
Thank you.
Thank
Thanks,
you.
Nick.